Hello my dear children of class 12 science. I again continue the same chapter that we were doing in the last class, that is photoelectric effect. Now this is one of the important chapter under the unit number 7. So as I said, there are only two chapters that we deal from unit number 7, but this is the chapter where you see more question that will be asked in the examination. Okay. Now in the last class we had done up to the topic that is the work function and the threshold frequency. Okay, now that work function and threshold frequency we defined especially from the graph that we had plotted, that is called kinetic energy, maximum kinetic energy, and the frequency of incident graph. So I am going to plot same graph, maximum kinetic energy versus frequency of incident radiation graph, but by taking the metal plate of different material. Because children, when Hertz and Lennard perform the experiment to observe photoelectric effect, they perform experiment not by taking the metal plate, which is cathode, okay, in a tube that is called evacuated glass tube, by one material. So they even perform experiment by taking number of material, okay, different metals, metal plate of different material. So what was observed with that experiment was the graph for all the metal, for all the different type of metals, okay, when they performed the experiment was found same. That means it was a straight line graph only, but the only difference in that graph it was found is, okay, your work function and the threshold frequency of that graph was not same. It was not found to be what? Same. But in all the graph, okay, the value of the slope, so I am using the word, the value of the slope which was calculated from the equation of straight line was found to be same. That's why, you know, last time in the last YouTube video I have explained this relation, EK equals to A mu minus B. So if you remember the last YouTube video which I have explained, okay, this is the equation of straight line from the graph which we have plotted, where maximum kinetic energy of photoelectrons is equals to A mu minus what? B, where A is a what? Slope, the slope of this kinetic energy versus frequency graph. Okay, mu is the frequency of the incident radiation, and we have expressed B as the what? Work function. Work function means the minimum energy which is required for the ejection of photoelectrons from the metal plate. Now to plot the graph again, so again I do in the similar manner. So I take two axes. One is x-axis, another is what axis? Y-axis. Now I plot x-axis as frequency of incident radiation, which is marked by letter nu, and y-axis I mark by letter Ek, and this is the maximum kinetic energy of photoelectrons. Okay. Now I plot graph of these two Ek versus mu graph by taking two different metals. So if I plot a graph, your nature graph will be same. Two graph will be a straight line graph which will not pass from the origin, but I'll give the name one of the graph plotted for one of the metals, say 1, whose threshold frequency was found to be how much? Nu naught 1. But they plot by taking different second metal of different material, okay, and the nature of the graph was found to be same but having different threshold frequency, and that threshold frequency I'll mark by letter nu naught 2. So you can see these are the two different threshold frequency, okay, for one metal say 1 and another metal what? 2. So from here I can say that the threshold frequency, okay, is completely depends upon the nature of the material, means the nature of the plate, the materials that we use in the plate which emit photoelectrons. Okay, so from here you can see that the threshold frequency, okay, the threshold frequency of metal 1 is greater than the threshold frequency of metal what? 2. Okay, threshold frequency of metal 1, this frequency is more than threshold frequency of metal 2. But you can see when you draw a backward line, okay, from this threshold frequency on the negative energy axis, this will meet at this point, so that I can mark this by a letter B1 with negative sign. And this negative sign of B1 is actually the minimum energy which is required to eject the electrons, and this minimum energy is called work function. This is what? Work function. But this is the work function for metal what? 1. Similarly, you can see for metal 2, if you draw a backward line, and this will meet on the negative y axis, that is the negative energy axis, and from this origin I mark by letter what? Minus B2. And this is also the minimum energy required to eject the electrons from metal 2. And this is also the what function? Work function. But this work function are also not same for different metals. So even they perform experiment by taking number of metals, that like we are doing out here with 2 metals, but the work function and the threshold frequency are completely different. Completely what? Different. But children, one thing I want to add, and I make it clear out here, is that when the frequency of the incident light is equal to threshold frequency of any metal, then in that threshold frequency the electron will just eject. It will just eject from the metal plate. Okay, but out here to define photoelectric effect, it's not only the ejection part also you have to do. That electron has to move with the maximum kinetic energy. But at this frequency, threshold frequency, and at work function, the electron will just eject from the metal plate. So in order to eject the electrons from the metal plate, so we must require the minimum frequency, and that minimum frequency is called threshold frequency, which are different for different metals. And even we need a minimum energy, and that minimum energy are called work function, and they are also what? Different. That's why threshold frequency and work function are completely dependent on the materials of the plate. Okay, the nature of the materials of the plate. Means by what material the metal plate are made of. So in that depends. But if you look at this graph, both the graph are a parallel straight line graph, but they are parallel to each other. And you know, when two straight lines are parallel to each other, what will be the same? The slope will be same. That means if you measure slope from this straight line this way, or even if you measure slope of this straight line this way, the slope will be same. And the slope of this straight line is measured by a factor A, and even this factor is what? A. So from here I can say that you take any type of metal, but the graph nature will be always a straight line having a slope. But even if you take different metals, the nature of the graph will be a straight line but have same slope. So but have what? Same slope. So from here I can say that this equation that we had used, and this equation represents the equation of this straight line, okay, so that A is a constant. A is basically a what? Constant, and this constant is called universal constant. This A is called what constant? Universal constant. And as I said, B is the work function, okay, which completely depend on the materials of the cathode plate, okay, and this B is called work function, and A is basically a constant, and this constant is called universal constant. So with this experimental observation, which was performed by this Hertz and Lennart, they made a law, and these laws are called the law of photoelectric emission. So we have what? Laws of what? Photoelectric emission. Laws of what? Photoelectric emission. Now this law which they made is on the basis of the observation, and whatever observation you learn, on that only they made the law. And this law is called law of what? Photoelectric what? Emission. But children, even they made the law, but one of the main problem that found in their experimental observation was they could not explain, and they could not actually say that and measure the value of this constant, the universal constant involved in the graph, in the equation. So that was the main drawback or defect that we can see in Hertz and Lennart experiment on photoelectric effect. Now the reason, as I said, is due to the case where they were applying wave theory of light. So children, wave theory of light was completely failed to explain photoelectric effect. So just listen carefully. Wave theory of light completely failed to explain photoelectric effect. Like in the wave optics, yes, you learn wave theory explain laws of reflection, refraction, interference, diffraction and all. Okay, but when we come to the photoelectric effect, it completely failed to explain photoelectric effect. But let me just come to the laws of photoelectric emission. So one of the first law of photoelectric emission says that the rate of emission of photoelectrons. So rate of emission of photoelectron means photoelectric current varies directly as the intensity of incident light falling on the surface. That means photoelectric current and intensity of light are directly proportional to each other. Number 2 laws say that the maximum kinetic energy of the emitted photoelectrons is completely independent of the intensity of the incident light. Means kinetic energy is independent on the intensity of light, but kinetic energy depends only on the frequency of incident light. But this number 2 statement says that the maximum kinetic energy of the emitted photoelectrons from the plate is completely independent on the intensity of incident light. And number 3 law say that the maximum kinetic energy of the photoelectrons increases linearly with the increase in the frequency of incident light. Means maximum kinetic energy depends upon the frequency of incident light. And it said that when frequency of incident light increases, kinetic energy also increases. And that you can easily see from this graph. This is the graph between kinetic energy, maximum kinetic energy, frequency of incident light. And graph is a straight line graph, which means kinetic energy increases linearly with the increase in the frequency of incident light. Now we have next law, that is the law says that if the frequency of incident light is below a certain lowest value, then no photoelectron is emitted from the metal, and this lowest frequency is called threshold frequency. And now this particular statement says that suppose you have a frequency of incident light mu that is less than nu naught, and nu naught actually is called threshold frequency. Then whatever intensity of light incident on the metal plate, but if the frequency of incident light is less than threshold frequency, then there is no ejection of photoelectrons, no emission of photoelectron takes place. That's why for the ejection of photoelectrons, the frequency must be equals to what frequency? Threshold frequency. And for the observation of photoelectric effect, threshold frequency must be frequency of incident light must be greater than threshold frequency. That's why under this condition, photoelectric emission will not take place at all. Now children, we have the last law, that is law number 5, and this law says that as soon as the light incident on the surface of the metal, okay, of frequency more than threshold frequency, there is a photoelectron emitted instantly. Means there is no time lag between the emission of photoelectron and the light incident on the surface. As soon as the light fall on the surface of metal, the photoelectron start emitting from the metal plate instantly only, immediately only, so that there is no time lag between incidence of light and the emission of photoelectrons. So this point is also very important that you need to understand. And this is also one of the point where these two scientists completely fail to explain photoelectric effect on the basis of what? Wave theory. So as per the observation, these are the law they made. But this law which was made by themselves was not able to put in experimentally, okay, and it was not verified experimentally, okay, with their experimental observation, because at the time they were applying the concept of what? Wave theory. So as per their observation, they say that this is the statement, but this statement was not followed in their experimental observation. So that's why I said that there is some drawback that was found, especially drawback in the sense there are some failure takes place in the application of wave theory in photoelectric effect. Means wave theory of light completely failed to explain photoelectric effect. But at the same time, one of the scientists called Albert Einstein, who put forward their experimental observation and their law, and he did some modification in the observation, okay, especially by using one of the theory of light called quantum theory of light. And that part you learn in the next YouTube video. And in the next YouTube video, we learn basically Einstein's photoelectric equation by using quantum theory of light.